Welcome to this session on harnessing the power of data with what we'd like to call now the Microsoft Intelligent Data Platform, and more specifically, I guess, the data services that we've got in Azure. So my name is Taygan Rifat. I am a cloud solution architect, or was a cloud solution architect for data and AI. I've just transitioned roles to another technical architect role, but essentially specializing in the data and AI services in Azure. And I'm joined here by Robin. Robin, do you want to introduce yourself?
Hello, so my name is Robin Lester. I'm a cloud solutions architect as well. And I tend to specialize in databases, data warehouses, machine learning technology as well. And I'll be doing some bits of this presentation.
Cool. So essentially the intent of this particular session is to do a kind of like whirlwind tour of the services that we have in Azure around data, AI, IoT, machine learning, all that kind of stuff. So a lot of building blocks. It might be a little bit overwhelming at the beginning, but then we'll try to kind of ground it and bring it to some common patterns and usual suspects, and even some reference architectures and stuff that we employ, and how some of this stuff is relevant to ISVs and developers. So some of these slides I'm about to walk through is stuff that you'll see if you go to Paul Henwood's session, which is after this, around Power BI embedded. But I think it's I thought it's worth bringing up because it's highly relevant to the things that we're about to walk through. So for a lot of ISVs and a lot of kind of software companies and developers, looking to do like data visualizations, analytics, and business intelligence embedded within your applications is a lot of what a lot of ISVs are looking to do to kind of enhance the kind of the value of their apps. And this makes a lot of sense, right? It's part of the kind of user's natural workflow. When we don't do it that way, typically we've got reporting and dashboards sitting in a central repository, which may exist outside of the app, and so that flow for the end user is quite disruptive. If I'm working within your line of your application, your solution, but I need to go get some analytics or some data, kind of shifting out and changing windows and changing screens to do that is quite disruptive. And so for partners and for ISVs particularly, there's a monetization opportunity potentially, right? So I think a lot of the software companies that we see potentially sometimes just look at, in-house reporting as what's the minimum that I need to do, just to kind of tick that box and ship off the minimum viable product. But a lot of forward-looking product managers are looking at analytics as a potential opportunity, right? It's relatively low cost, it's high margin, and we've got technologies like Power BI Embedded that help facilitate that. So if you are interested in Power BI Embedded and how you can take visuals from the whole Power BI product portfolio and embed that within your own custom solutions, Paul's session at 2 o'clock is going to go into that in depth. And that's essentially this bit on the right-hand side. In terms of this session, what Robin and I are going to focus on is more of what's going on the left. How do I back that by industry-leading data storage, analytic, and compute services to kind of connect to a wide variety of different data sources on the left, structured, semi-structured, unstructured, what have you, pull that in, persist it, transform it, enrich it, and then serve it out to these visuals that can then be embedded within these kind of custom solutions. So that will kind of be the focus of this session, but if you are interested more on what's in the yellow box, that will be Paul at 2 o'clock.
Okay, so I'm going to be talking to you generically about data, and I'm going to make some assumptions about the kind of people you are. I'm assuming that you all have data, because if you haven't, why are you doing here? And I'm also going to assume you have databases, because if you have data, you're probably going to be sticking in a database. Okay. So we'll focus a lot of the stuff that we're going to be talking about today on the next stage on, from just data, putting stuff into databases, putting it into a data warehouse, but we'll still talk about the whole stack. Anyway, data, you may have heard this before, data is the new oil. Why is it? Why do people refer to it as the new oil? Because there's lots of value in data. If you can mine the data, if you can refine that data, that's going to give you lots and lots and lots of ability to gain insights. It's going to lead on to being able to use that to create new aspects of your applications and services. You're going to be able to take that and start doing artificial intelligence with it and giving yourself it's some unique selling points. So you'll probably, as ISVs, you probably understand the importance of data. But also, the downside of data is that it's polluting. So it's polluting on two main levels. Firstly, if you start accumulating data, and you've probably seen all those statistics about how much data everybody generates per year, and it's a ridiculous amount of stuff. It's gigabytes and gigabytes per person on the planet is being generated. If you're not dealing with that data properly, just like if you weren't dealing with oil properly, it will turn into a big mess. So we end up with concepts like data swamps, where your data is all over everywhere, and you don't really know where any of that data is. And if you want to get a piece of that data, it's really difficult to find that piece of data because you haven't really thought about your architecture properly. And then also it's polluting because the more data you have, the more you have to process it. And to process it, you have to take up CPU cycles. CPU cycles take up electricity. Electricity produces carbon. So there's a segue into Microsoft and sustainability. So if you take your data and you stick it into the Microsoft cloud, you are at least taking the first steps in making sure that the pollution that is generated by having a lot of data and refining that data is offset. So by 2030, pretty much we're going to be carbon negative, water positive, zero waste. So stick it into an Azure data center means that your carbon footprint will be much less. Okay, so today's data realities. So with data, we have to think about how useful is that data, and is that data giving you the things that you want to produce from it. So people always said, when we used to talk about data, back in, 2012, we had the whole concept of the 3 Vs. We had volume, variety, velocity. You've probably all heard of this. It's very common, 3 Vs of data. But really, in reality, there's more than 3 Vs. There is 10 different Vs, okay? So, and this is a really good way of starting to think about your data and thinking about how you use that data to do, if that data is relevant to you and what you might be using that data for. So we have volume, amount of data, velocity, variety, so the type of data. Variety starts to lead into thinking about, do we need to employ machine learning? If we've got pictures, we need to strip out and put it into tabular, because with your data, usually the end point of your data is to put it into a tabular framework so you can push it out and read it with some reporting technologies. Variability, so inconsistencies in the data. Validity, so how accurate is that data for its intended use? This kind of leads on to the conversation about data quality. So who here believes they've got a data quality problem? Put your hands up. Okay, so so people that didn't put your hand up, you've got a data quality problem, but it's worse for you because you don't know about it. So data quality is really important. So how good is your data? How vulnerable is your data? So if you're storing PPI data, is that going to be, are you storing it in the right place, the right area? I always like to talk about this one, volatility, so the age to relevance. This is usually a conversation that is a difficult conversation to have, because how do you know when your data is going to be irrelevant? Often we talk to people that are handling data, they have data in the databases, they go, actually we're going to archive this stuff off, we're going to bin it, we're going to lose some of the data that comes through in our feed because we don't think that's relevant. A couple of years down the line they go, oh my god, I wish we had that data, because now we've moved on to more advanced things, we've moved on to doing some data science, and that data would have been critical for being able to understand the pattern of our customers or usage cases or something that's going to give us a competitive advantage. So I would say if you've got data, you have to think really, really carefully if that data is going to become irrelevant. Now, obviously some data will. Network traffic might become irrelevant if you're not moving in that space, that kind of stuff. Visualization, how easy it is to visualize. As I said before, normally you want to go to a tabular format. And value, how much value does it give to your business? If the data's not giving you any value now or in the future, it's probably data that you should consider if you don't want. But sometimes you can't always realize the value of data until you're in the future and you've started actually thinking more about what that data might give you using more advanced tools such as machine learning. Okay, so we have the Microsoft Intelligent Data Platform. So what does this, what exists in our platform? Now, we have, as Microsoft, we have tools that we produce ourselves, and we also embrace open source. So you might be surprised to know that Microsoft is the largest contributor to open source in the world. Yes, we contribute more than Google, more than, I can't think of anyone else. Someone else that does lots of open source. So we contribute, and a lot of the stuff we're doing is we're taking innovations, we're making them enterprise ready. So if you know, a new machine learning library might come out, we will make sure that that's enterprise ready. Okay, so we have tools to allow data governance. So we have Purview, we have tools for analytics, and we have our operational databases. And as like I said, open source. So you can, if you're using MySQL or Postgres, you can use them in Azure. If you want to use SQL Server, you can take SQL Server and you can use that in Azure as IS offering. So SQL Server, Azure SQL, Cosmos DB. Cosmos DB, I hope everyone knows what Cosmos DB is now. It's kind of like a NoSQL database, so really good for storing things like JSON and stuff that is loose schema. Azure Sign Up Analytics, which I'm going to go into detail in a bit later. Power BI, which is pretty much a presentation there. If you're interested in Power BI, Paul's going to be doing a really great presentation on Power BI after lunch at 2 o'clock, I think. We'll talk about Purview and then Azure AI. So we have lots of tools in the stack in AI. Things that we've kind of gone through a process of democratizing AI. So we are making AI accessible for people to be able to use. So if you're an ISV and you have an application and you want to put something, you want to start doing some AI into the application, you don't necessarily need to go off and buy lots of books on Python and understand all about all the different algorithms that there are there. We have tools such as the Cognitive Services, which is basically just a call to a web service. You can even, we even have custom cognitive services as well. So, for example, you could take voice to speech, and we have cognitive voice now, so it's almost identical to a real person talking, and you can pay an actor and pay that actor to be able to train that voice, and so then you can have that voice of your organization. So whenever you need a voice, you can basically type it in and it will say it in the pattern of that person. Obviously you have to pay them. You can't just take Brad Pitt's voice and that's now the voice of my application. You'll get in trouble if you do that. Okay, and it's not just Azure. We have three main clouds: Dynamics, 365, Microsoft 365, Power Platform as well. So all of these things obviously work together and integrate together. And yeah, let's move on to this. So I thought I'd put this slide in here because this is with the kind of challenges we typically see with ISVs, the problems, and these might be really familiar to you. Hopefully they are familiar to you. And this is where we as Microsoft can help, and as partners can help you as well. So normally it's normally you have a capacity issue. So most ISVs we find are that don't tend to have lots of people just sitting around as resources, not doing anything. So you're normally doing business as usual. Everyone's dead busy. It's really hard to move into new areas, into building other stuff. So what do we do as Microsoft to try and help ISVs? We democratize our technologies, so we make things easy. So as I said before, machine learning, we make machine learning easy for you to consume. We give you familiar tools. So as we see when we talk about Synapse later on, if you come from a SQL background, you can just start using SQL in Synapse. It's the same language. You don't have to necessarily cross-train. And we do that with a lot of our technologies. So if you're a Python developer, we give you SDKs for Python. If you're a C# developer, we give SDKs for C#. So a lot of familiar tooling, so you can transition into these new technologies easily. And we also try and give you the single pane of glass. I've spelt pane wrong, haven't I? Yes. Have I? Is that right? Yeah? Okay. Single pane. Okay. Single pane of glass for technologies. So what we mean here is when we talk about Synapse, we're giving you all the technologies within there. When we talk about Azure Machine Learning Studio, we give you all the technologies in there as well. So if you're a data scientist, you can just go to Machine Learning Studio, and that's everything you could possibly need. If you're a data engineer, you go into the Synapse workspace, and that's all the technologies you want in there. I'd like to say, we'll be talking a bit more about Synapse later, so you can understand what that kind of suite of technologies looks like. We also find capacity is usually an issue for ISVs, so having the capacity to do things, start doing data science. So normally that would sit with the practice build. So it's always the kind of conversation of, do you cross-train, or do you add new people to your team to be able to facilitate that? And the last one is when we talk about practice builds, customers, being able to get new customers, being able to talk about the new service that you're developing with those customers. So being able to hunt and identify issues, hunt and identify, issues, problems that your customers might have that you could then monetize. So for example, if you have started doing, a classic example is the machine learning space. So if you started doing machine learning, and you will have lots of customers. Let's say you're a data provider, you do databases for people, that kind of thing, and you start to do machine learning. You need to be able to identify with those customers where you can help them in terms of machine learning, as opposed to just always thinking about the data architecture. So normally, where you can have support, Microsoft, etc. We'll help you with kind of pre-sale support. We'll help you identify what you need, conversation you might need to be having with those customers to identify those opportunities. With that, I'll pass over to Taygan.
Cool. Thank you. Okay. So I thought it'd be useful just to kind of step through the typical data to action or data to insight journey, and then we'll go into some of the different kind of building blocks and hopefully try to boil them down and make some common sense of a lot of the stuff that we've got in Azure. So, and obviously the kind of list of things that we have in those boxes is not comprehensive. That space changes quite a lot, but the layers and the journey that the data goes on is kind of remains relatively consistent. And so, on the left-hand side, we have data of all different types. So when we talk about structured data, we're talking like relational, stuff that might sit in a SQL-based store, so in a SQL database. Semi-structured data, that's typically like in a JSON format. I think Robin mentioned Cosmos DB, so if you've got a document-based data store, you might have some semi-structured data. And then completely unstructured data, so that might be video files, images, audio, things like binary documents. And there's still some insights that we can derive from there, but maybe not in that really raw form. There might be some stuff that we need to do, pull that in and start to enrich it. But typically, like as we work our way from left to right, there are some services that we're going to need to engage in order to, one, do that initial ingestion. So these sources might exist in other clouds, they might exist within the cloud that we're operating in, might sit behind APIs and SaaS services. So how do we kind of engage some type of ingestion service to kind of pull that data in? Once that data is ingested into our data estate, we need to persist it somewhere, and typically we'll have common cost-effective data source like Data Lake, which we'll get into in a little bit. But there's a wide variety of data stores that serve different purposes and are optimized for different things. And then once that data is persisted, engaging some type of compute or a mixture of compute to perform analytics, to enrich that data, to maybe stitch it together with other things, to transform it, to cleanse it, to Robin's point around data quality. And then finally, once we're on the other end of the spectrum, kind of using things like Power BI to kind of visualize and serve that out to either people, processes, or in a lot of ISV cases, applications. So that's kind of how we see the data to action journey. But like I said, a lot of the kind of tools in the chess box might change, and they keep evolving, particularly when it comes to cloud. This slide is something that I found really useful when I was kind of on my own journey to understand what the hell is going on in what was called Cortana Intelligence Data Suite, I think, back then. This is over 5 years ago. So there's a colleague of ours in the US called Buck Woody, so credit to him for this format, but I felt that really worked for me, working kind of in these layers to really understand there's a lot of stuff that you have. Can you boil it down to me in terms of the crux of what it does? And then I've got a rough idea where everything kind of sits. And this format has really kind of resonated with me. So I'm trying to replay it basically for you. And right, so even Azure Data Services. So we've gone from Cortana Intelligence Suite, Azure Data Services, and then you saw on the slide before, Microsoft Intelligent Data Platform is like the latest thing from the marketing team, right? But essentially it's the same suite of tools that we're talking about. So again, this is not comprehensive, but I'm going to work my way from bottom to top, and I'll try to articulate, I guess, what each of these layers or these groupings of services ultimately do. Like, what's the crux of it? So, Microsoft Purview, formerly known as Azure Purview. You can think of Microsoft Purview as the equivalent of a yellow pages, right? So if I'm looking for a business or a phone number, I'm looking for their details, the yellow pages, I kind of swipe a couple of pages, I go to the right page and I can find the details of that. Microsoft Purview is essentially that for data. That is only one component. So the way that Microsoft would pitch it is it's our unified data governance service. Now, data governance has a lot of different disciplines: data quality, data catalog, data use management. All of that stuff you're going to see us investing in Microsoft Purview. So it'll be that kind of one pane of glass for data governance. But the data catalog is one big component that a lot of people are leveraging at the moment. So it's like, how can Purview connect to all these different sources of data? They don't necessarily need to be Microsoft sources. They could be Oracle, SAP, multi-cloud, on-prem, SaaS. And Purview will have visibility of all of that so that your data consumers or data workers can go to Purview and say, hey, I'm searching for sales data, where's the sales data? And they'll kind of search in like a keyword fashion, and they'll find the different assets and be able to connect and then start to work with that data. So the way that I like to think of Purview is docket, right? We're documenting all that metadata into the one repository. Azure Data Factory, Azure Data Share, and Synapse pipelines. Essentially what these services have in common, they're all our data movement services. So if you have a requirement, and I talked about ingesting data from some other source, if you have a requirement to grab some data from source A and then move it to destination B, you're probably going to be using one of those services, most likely either Azure Data Factory or Synapse pipelines, and I'll explain why we've got one that does more services that do the same thing. So that might be on-prem to cloud. That's obviously a common scenario. It might be cloud to cloud, like AWS to Azure, preferably in that direction. Or it can even be within Azure itself, right? So you might be moving some data from blob storage into SQL. So if you've got that type of requirement, which we would call ETL or ELT, extract, transform, load, Azure Data Factory or Synapse Pipeline is probably going to be the two services that you're going to look at. Why do we have two things that do the same thing? Basically, Azure Data Factory was there first. Synapse Pipelines, it's the same code base. It is ultimately Azure Data Factory, and you'll see with Synapse it will be mentioned multiple times because Synapse is essentially a platform, and we have all these different capabilities within Synapse, so you don't have to spin up these distinct services because Synapse can do a lot of things under the one roof. That's why it exists in two places. Azure Data Share, that does do data movement as well, but that is more purpose built, and it kind of stands on the shoulder of those services. So if you have a data sharing requirement, so that might be B2B. So if you've got data as an ISV, maybe you have like sharing agreements with your customers. Potentially you're facilitating that now with like SFTP and email and maybe some not so secure ways. Azure Data Share would be the more secure way of doing that. So I'd like to think of that as move it. Event hubs and IoT hubs, so these are our big data streaming services. So if you have any big data streaming, right? So it could be coming from an IoT device, in which case it would be geared towards IoT hub, or maybe it's just this big streaming API and you want to ingest that into the cloud, into your data estate. You're going to want to use one of those two services. That will be the endpoint in which you'd point that streaming data to, because it needs to be pointed somewhere. Otherwise, it's like a fire hose that's got nowhere to go. I used to work for there was a contract I did for like a water utility company back in Melbourne. And so the example I like to give with them is that so they're the equivalent of like Thames Water, and they had all these kind of pipes running all over the place. Over time, those pipes would kind of break. They'd crack and they'd burst, and they'd have to send engineers out to go and like fix it, right? So at the time, they were contemplating, what if we could predict if those pipes were going to break before they break, and then we could send the engineers out proactively. And to do that, they were looking at IoT. How can we attach these IoT devices to a pipe that IoT device might detect things like soil moisture, water pressure, amongst other things, and then it would send that data to something like IoT Hub. Now, that individual packet, like at this point in time, the water pressure is 85%, is not that big, but then you scale that out, right? That IoT device is one, it's sensing that one thing, it might sense that thing many, many times in a second, there might be many sensors, and then you scale that out to the fleet of the network. Very quickly, you can be talking about thousands, hundreds of thousands, or even millions of events per second. So these types of services are able to kind of scale to that size. And so that's the way I like to think about it. It's like bring it, you know, we can handle that, we can handle that stream, and then from there you may do other things, but now it's in the cloud. Azure Blob Storage and Azure Data Lake Storage. So these are our object stores. Really, really cost effective. It's just one of the inherent benefits that you typically get when you're in the cloud. You know, storage is decoupled from compute, so it doesn't cost as much. The equivalent in Amazon, I think, would be like S3. So if you that's kind of our equivalent in that space. But essentially, these storage services, they scale to the tune of like exabytes, so you're not going to have to worry about how big can this thing grow. And with Data Lake specifically, again, that just sits on the shoulders of blob storage. It ultimately is blob storage underneath the hood, but there's some things that we've turned on specifically for analytics. So we call it, without getting too technical, a hierarchical namespace, but it's just a fancy word for folder structure. And it means that the data that we ingest into the data lake, we can partition into different folders. It's really good for analytics service because then they can start to process this data in parallel, because now it's like, it's all separated into folders. It's not just one flat structure. So very common landing area for a lot of the data that will come into your estate, and so I'd like to think of that as store it. Azure SQL Database, Cosmos DB, Synapse SQL. Again, this is not an exhaustive list. We've got other database services as well in Azure, but these are essentially some of our first-party SQL and NoSQL data stores. Yes, there's overlap. Obviously, they are storing data as well as is Azure Data Lake and Azure Blob Storage, but typically, when you're choosing one of these services, you've probably got a specific need that you're servicing, right? So it might be, I've got an application, it writes a lot, it doesn't read as much, I need something that's kind of optimized for transactional workloads, so I might choose Azure SQL Database. Or you might have an API and the schema is a little bit fluid. I'm going to store things in JSON, I might want Cosmos DB for something like that. So depending on what the exact requirement is, you might pick a specific type of data store. But ultimately, I'd like to sum this up as kind of like serve it, right? You're serving a line of business application, an API, or maybe some enterprise reporting and analytics out of a dedicated SQL pool in Synapse. HD Insight, Azure Databricks, and Spark within Synapse, these are all our big data compute engines. So if you've got all of this data that's kind of being hydrated in your data lake, we need big data compute engines to work with that data, to wrangle with that data, to transform it, enrich it, to allow the data engineers some type of framework that they can kind of write code and start to manipulate the data before it's ready to be consumed by end consumers. And so those services, you know, while there might be different reasons why you choose one over the other, maybe you have an existing Hadoop implementation, so HD Insight might be the path of least resistance for you. Ultimately, otherwise you've got Spark and things like Synapse and Databricks. But a common theme across all of them is that they're spinning up clusters of compute, like a cluster of virtual machines, so that they can work on this data and process it in parallel. And that's kind of the common thread across all of them. So I'd like to think of that layer as just scale it. Stream Analytics. So Stream Analytics would be something that would sit in front of something like Event Hub or IoT Hub. So the example I usually give is that we've got a fintech company, and they've got credit card transactions that are being streamed in. So these every time someone does a credit card transaction, it streams. Stream Analytics allows us to express, put a job or some business logic to query that data in real time. So if you want to query that data as it's coming in, not after the fact and near real time, you can express that in a Stream Analytics job. So we might sit that in front of the credit card transactions, they're coming into Event Hubs, and in the Stream Analytics job, I might say, you know, if over a tumbling window of 8 or 12 hours, if I see 2 credit card transactions, one happened in London, the other one happened in Sydney, there's no way someone could have traveled that time travel those 2 locations in that space of time I'm going to flag that as potentially sus, right? That's fraudulent. I might want someone to do something about that. So that might trigger like an Azure function or something like to do some post-processing. So that type of logic, you write it in SQL and that kind of gets stored in Stream Analytics. But yeah, if you want to query data as it's streaming, Stream Analytics is the service for that. So stream it is the way I like to summarize it. Azure Machine Learning, Azure Cognitive Services, I think Robin touched on this a bit. So this is essentially a very, very high level grouping of all of our AI, ML capabilities. And there's kind of like two sides of the fence. So on one side, probably very relevant to ISVs, like I want intelligent capabilities within my app. I want to do things like speech to text, OCR, key phrase extraction from a whole, a bunch of text. Those types of use cases, Microsoft has like a growing list of things that we've kind of solved, and we're serving those out as APIs. So you don't have to have a PhD or have data scientists within your team. There's a long list of things that we've already pre-built, which we kind of surface up through this branding of Azure Cognitive Services, and they're just API endpoints. So we like to describe that as our model, but it's your data. So you provide the payload, and so that might be an image or a bunch of text, and we'll provide you the insights. How the black box works, it doesn't really matter too much. It's just you're paying for the API requests. But on the other end of the spectrum, it's like, well, what if I do have data scientists and I do want to do something a bit more bespoke and custom? They might want to roll up their sleeves and write some code in a Jupyter notebook, all that kind of stuff that they're used to. Azure Machine Learning is essentially the platform that we offer to make them really productive. How do we go from training something custom to publishing it to having some type of inference endpoint and something that's production ready? Azure Machine Learning is this kind of platform of tooling and services that helps the true data scientists in the true sense do that. I'm overgeneralizing a little bit, but ultimately that's kind of the two. And so the way I like to think about that is predict it. And then finally, obviously, we can bring data in, we can persist it, we can work on it and transform it, but at some point we're going to need to see it. And so Power BI is our data visualization tool. If you've used other things like Click and Burst and others, it's our equivalent of that. But Power BI is, you might be very familiar with Power BI Desktop. If you check out Paul's session, I think he has a slide that touches on the entire Power BI product portfolio. At the very, very high level, and so you'll kind of get a good feel for what the whole suite has to offer. Like Power BI Desktop is just one bit. So hopefully that gives you a bit of a feel for Azure Data Services or the Microsoft Intelligent Data Platform. Again, not a comprehensive list, but we'll try to boil that down into kind of 2 words. So conscious we've gone through quite a bit. I'm going to try to bring that back now. Because the thing is, when you're building these solutions, you don't have to touch on every single one of those components, right? And there are a lot of usual suspects, common patterns that people employ. So again, we start with all the data on the left. We have these kind of the journey that data is going to go on from ingest, store, all the way through to reporting. This is just one example, and probably like if you search on Azure Architecture Center, you might see some of our reference architectures have stuff like this, though even the story is changing a little bit, and Robin will kind of talk about how Synapse is touching on a lot of these areas. But one example, so ingest, Azure Data Factory or pipelines in Synapse, that's probably going to be the service that you're going to use to pull data in. It connects to, I think that's our data. I think it's 100 plus data sources. We have a lot of generic connectors if there's not something in that list for you specifically. And that's going to help pull data in, orchestrate any transformation that needs to happen, and ultimately land it and persist it in some cost-effective store like Azure Data Lake Storage. Once it's persisted, Spark seems to be more and more popular these days as the kind of computing framework for data engineers and data scientists to use to kind of work with that data, wrangle with that data. So whether that's Azure Databricks or again, and I don't want to steal Robin's thunder, but Spark within Synapse, but Azure Databricks could be used to do that data preparation. Then dedicated SQL pools, which used to be called Azure SQL Data Warehouse back in the day. It's optimized for analytical queries where we're doing a lot of aggregations, not write heavy, but analytics and read heavy. We might serve that data when it's in that curated form in dedicated SQL pools in Synapse, and then ultimately use something like Power BI to visualize that and surface it. And remember, any of the content that's built there, you can then embed in your own applications with Power BI embedded. And with that, I'll hand over to Robin.
Thank you. Okay, so the kind of conversations we normally have with ISVs sit in kind of three main conversations when we talk about the data estate, common conversations. So the first one is, how do we migrate to Azure? And so we've got lots of tools in the box that help you with that. We have the data migration assistant, it's usually a good starting place. And we have the ability to go from things like Oracle database into Azure or Oracle to Postgres. So that's one of the conversations. Second conversation we normally have is around, how can we save money in Azure? So we've moved into Azure, we're using Azure SQL database. How do we do more dense computing? And so those conversations normally go around talking about SQL Elastic pools, being able to share resources for your databases. Maybe talk about SQL serverless as well, so having a database that will turn itself off, come online, being able to tier your database services, so you're sharing resources for kind of bronze style customers, and you're not sharing resources for gold style customers. So that's normally the second main conversation we have with ISVs in the data space, trying to cost savings, dense computing. The third one is talking about data warehousing. So taking your data, putting it into a central location, be able to run predictions on that data, being able to analyze that data. And we're talking about sustainability before, and this kind of leads into sustainability again. Being able to, if you take all your data and put it into a central location, you're going to be able to understand what's happening across your estate, and you can see, what's going on, which leads into being able to understand how much your carbon footprint is, etc. But anyway, so going back to data warehousing, now the kind of main concept that we always try and get across if you're coming from a traditional data platform is to break the idea of ETL, because ETL's been around for a long time. ETL is extracting the data, you transform the data, you load it into a database, or traditionally you'd stick it into a database. Why we try and challenge that is because numerous times we see people transforming that data, and then there's a problem in the transformation of that data, and the data's being loaded into a database, and you might be extracting that data from a FTP site that is a customer is giving you, or somewhere else, and that data may no longer be available. So you might get yourself into a situation where you've been bringing this data in over 6 months, and then you realise there's a problem in your transformation, and then you go, well, hold on, how do we fix that? We can't fix that, because we can fix it going forwards, but we can't fix it for the data going back. So, so when we talk about, we don't really so much talk about ETL now, apart from ELT. So extract the data, load it into something like a data lake, and then do your transformations. Data is really, really, really cheap to store in public cloud. So bring your data in, stick it in a raw form into a data lake. And when I talk about data lakes, I'm not necessarily talking about Azure Data Lake v2. It is a product, and it's a great place to have as a data lake. Data lake can just be a conceptual idea. You could have a SQL database, could be a data lake, as long as you're following the principles of what a data lake is, i.e. you're loading data in, it's immutable data, so you load data in its raw form, you don't change that data. If you need to change anything to data, you move it into another place in that data lake, and do that, and do the alterations you need. So traditional scenario would be extract the data, load the data, do data quality on the data, do transformations on the data, move it into another aspect of your data lake. Then we have these concepts of bronze, silver, gold. So you have the bronze layer, which is your raw ingestion. You have your silver layer, which might be, you might call it staging, where you've done transformations. And then you move it into your gold layer, which is, you could say, was your semantic layer, and it's the data and its prime form being able to push out to in the end state. So, so that's the new way that with the massive data explosion, that's the new way everyone's really thinking about data. So we have Azure Synapse Analytics, which is a product that encompasses all the tools you might want to do to be able to do to be able to manage your data effectively and properly. So at the core of it, we have Azure Data Lake Storage, V2. As Taygan said, it's a hierarchical namespace. Essentially, blob storage, as the name suggests, is just a big blob. So if you want to get a file from a blob storage, you have to run down all that blob, find that file, extract it. Whereas Azure Data Lake Storage is hierarchical, so it works similar to a server or laptop storage system. So they have a file allocation table. Basically, it's kind of like an index, so it knows where all the files are. So when you want to read a file, it will just go to that file and bring it out without having to run through the whole of the disk to get to it. So much better at running for large amounts. If you've got a large amount of data and you want to extract bits of that data, that makes it much more efficient way of doing it. So that's why we talk about Azure Data Lake Storage. We also have Synapse Link. So this is the ability to, we have a Synapse Link for Dynamics, and we have in preview 1 for SQL. This lets you connect to, so we talk about SQL 1, which connects to a SQL database and be able to run analytical queries on that data from Azure Synapse Analytics. Let's actually talk about what is in the box with Synapse Analytics. So Synapse Analytics, one component of it is what we used to call Azure SQL Data Warehouse, which before that we used to call APS, which before that we used to call PDW, PDW, Parallel Data Warehouse. Basically, it's a massively parallel database system. So under the hood, it's 61 SQL database. We always say it's 60, but really it's 61 because there's a head node. But 61 SQL databases, the data gets shared across those databases. When you run a query, they all share a bit of the data back and push it up to the head node, and then give you the results. So very much a big data solution. One of the successful big data solutions from the big data revolution. I mean, the big data revolution was started in around 2012, and around that time, obviously as Microsoft, we were dealing with lots of organizations that were trying to do big data solutions. We were finding that their solutions were only being successful around 5% of the time because lots of people didn't really have big data problems, and the toolings at that time were basically rubbish. People were writing those toolings because they were excited about adding new features and stuff. They weren't thinking of enterprise, and they worked pretty well, but only up until a point, and the level of complexity suddenly shot up. I mean, we had languages such as Hive, which is SQL-style language, which was great. You can type SQL, you can query the data, until you had to have a problem, and then it gets very, very, very complicated to work out what's going on and work out how you're going to make that more efficient. So since that kind of big data revolution, a few technologies have kind of surfaced. The concepts obviously are there, but a few technologies have surfaced, such as we talked about Synapse Analytics Database, which used to be called Azure SQL Data Warehouse, and Spark as well. So Spark is a technology, you'll probably hear it referred to a lot as an in-memory big data technology. We call it in-memory, it's not just in-memory. It tries to do everything it can in memory as much as possible, because one of the main problems with big data solutions was the fact that they were always pushing out to disk and reading from disk, and if you touch a disk in an architecture, your architecture is going to be slow, so you should always try and avoid disk access as much as possible. So Spark kind of bubbled up and came on top because it was fast, efficient, it was easy to use because it had different capabilities, but they were all written by the same developers, so that you interfaced with them the same kind of way, as opposed to all the old big data technologies where you might have Hive or Pig or Oozy or all of those different ones, and all being written by different people. And so when you're trying to connect and talk to them, you're going, oh, hold on, how am I going to talk to this? What language am I using? Am I going to write stuff in SQL? Do I have to write it in Java or Scala or whatever? So Spark, it's a nice interface. Everyone, you use one bit of it, it will make sense using another bit of it. And it's got all the key technologies you might want to use in there. So we have Spark Streaming, which basically is a micro-batch streaming engine, so you can do transformations on inputs in stream. So if you, I always use the typical example of Twitter is my favorite example of why you might want to do streaming. So Twitter, with all the tweets coming in, they can't wait for those tweets to land on a disk before they start talking to them because disks are slow. So they invented a system called Storm, big data system called Storm, that would let them do transformations in stream. And then along came Spark Streaming, which is similar kind of concept, but deals with the data flowing in before it touches disks, so you can do all your transformations in extremely fast time. So we have Spark Streaming. We have Spark SQL, so you have a SQL style language there. We have different kind of language you can use there, so you can use Scala, and you can use PySpark. So PySpark is a form of Python designed to be able to run over multiple clusters. So one of the downsides of Python is that it's generally single nodes. So if you have a big query and you want to process, put it into a data frame, and you've got 1 billion bytes worth of data, you're going to need more than 1 billion bytes worth of memory to hold it into that space. So PySpark was kind of invented to alleviate that problem, so you can have multiple nodes out and you can push the data across them, and they'll all do a bit of the processing of your data frame. We also have, so we have, let's finish Spark off. So we also have the graph database as well in Spark, and we have machine learning. So we have some machine learning technologies in there, which we've actually added some additional ones. So there is ML Spark, and then we've added Microsoft ML Spark, because the number of algorithms you get in the Spark machine learning library is okay, but it's a bit limited, so we've add more. And you can also use it to go and talk to cognitive services as well. So if you have a massive amount of data, you can go and talk to cognitive services with multiple nodes and get and process a massive amount of data quickly. So there's Spark. Then we have SQL. So we talked about Azure SQL, what used to be called Azure SQL Data Warehouse. We also have, which I will now refer to, dedicated pools. We also have serverless pools. So serverless pools is the ability to run SQL statements on a data lake when the data is at rest. And so these SQL statements you would run will be statements that are accessing the data, putting the data out, pushing it out. Traditional SQL to run this. Why would you do this? The advantages are that you can just pull your data in, push it into your data lake, forget about the data until you want to access it. It's nice and cheap to store. And then when you want to query it, just use serverless SQL, and you will pay, the pricing is 1 terabyte's worth of processing costs $5. So you can process a lot of stuff and not actually have to pay much. Pay as you go. So if you don't process, if you only process a terabyte's worth of dollars in a year, you're only paying $5 to have that, use that service. So this is what we refer to as the data lake architecture. A data lake house architecture. So data lake house architecture is putting data in a data lake and querying over the top of it. So within this, we encapsulate all these technologies in Synapse Studio, and we also have things such as Data Factory in there. We integrate with Power BI. We have Power BI in there as well. We have KQL, Kusto Query Language, if you want to do any big queries over a massive amount of log data. What have I missed out? Okay, let's go to, so that's what, I'll just do a demo in a minute and show you some more stuff. Okay, so one data warehouse, you'd normally have to have all these different kind of technologies working together. So as Taygan talked about, we have Azure Databricks. Azure Databricks is basically a Spark cluster. So the people that wrote Spark, a lot of them went off, formed a new company called Databricks, and that's where we get Azure Databricks from. So open source, but in Synapse it's also open source. But it's usually caused a bit of confusion. Should we use Databricks? Should we use Synapse Spark pools? Normally, we would say if you're doing something that is machine learning first, we would suggest use Databricks. If you're doing something data engineering first, use Synapse, because within Synapse you have lots of other tools especially if you're coming from a SQL style background. It's going to be much easier to use. Okay, so modern data warehouse, you have data factory coming in, you're processing the data, you have all these different components, but really we can replace this with Synapse. So this is what we're talking about, a single pane of glass for your data engineer. You don't need to worry about, everything's there, everything's in here to work with. So traditionally you might have your pipelines, which is data factory, moving the data in to your data lake, and then querying it out with serverless SQL for going for a low-cost data lakehouse style solution. Okay, so shall we show you what it looks like? Okay. So this is, if I can find my mouse, here we go. This is your Synapse workspace, what did I press? I pressed something wrong. Synapse. I'll tell you, just go back, shall I? It's the easy way. Synapse workspace. And open Synapse Studio. Like I say, this is everything you need. It's a kind of data engineer. Okay, so within it we have our home page. We have, in fact, we could create a new script from here. We have some examples as well down at the bottom, but I'm just going to show you the kind of basic stuff. So let's start off with data. So within here, we have access to our data lakes. So as you can see, here's one, Azure Data Lake Storage Gen 2. But we could talk to Cosmos, Blob Storage. We could talk to data sets that we've created in Data Factory. So I'm just going to go in and show you how easy it is to start understanding your data. So as you can see, whoever created this has thought of the bronze, silver, gold kind of concept of bronze will just be our raw data that we need to do data quality on. Silver will be data quality data. Gold will be the best view of the data that you're going to push out to your customers or to reporting. But within here, so I have this. So this is just files on my data lake. We have some in Parquet. We have some in CSV. Parquet is a columnar style format. It's very efficient for doing OLAP style queries, so kind of data warehousing style queries. So normally what you do is you load it into your bronze layer as its raw form. You'd transform it into something more performant, such as Parquet, and then you'd be able to start playing around with it. So I can go in here, say I want a new SQL script based on that. It is a Parquet format that I'm reading, and then it will give me the SQL. So now I'm in my serverless database. Like I said, this costs, I could do a terabyte worth of data processing for $5. And I can run this. I'm connecting through the web, but I could also connect through SQL Server Management Studio or any other kind of data tool that can talk to SQL. So that's querying that. Normally it's a bit quicker. It's because I'm demoing. It's going to be running slow. There we go. Right, so I can see what's in here. I could also say, so this is all my Parquet files here. I could put an asterisk here to look at all the files at the lower level, an asterisk back, and so I could just look at, any branch on the tree and all those files in here. It's basically looking for any files under this folder, and so I've got my data out. So as a data engineer, I can start playing around with that. I also have the ability to go in and visualize that. So out of the box, we have charting here. So I can see what this data looks like. Now, if I didn't want to look at this view, I could look at it as a bar chart or something. I could look at it as a pie chart, etc. And I can, that's rubbish, isn't it? I can look around this, change the stuff. Oh, what should I do there? City, category, zip maybe. No, okay. So I'm obviously not a very good data engineer because I can't visualize that as pie. But as you can see, we can go in and we can look at the data however we want to. Okay, I'm running out of time, so let's quickly show you some other aspects of here. So we have ability in here to develop, so we could just write SQL scripts in here. So actually, I've actually got a new SQL script I've created in here. We can talk to JSON in here, if our data is held as JSON. Or we can store these scripts in a database. That database itself will be it basically just metadata, understanding how to talk to the underlying storage systems. We have KQA, Custo, query language. We have notebooks as well, so we can go in and we can use some PySpark or some Scala against our data lake. So here we go. This is Python. This is PySpark using here. So as you can see, visualize that. And what does this run on? We would go down into manage, and we would choose what we wanted it to run on. In this case, we'd use a Spark pool, so we'd create a new Spark pool. And those Spark pools, basically, you can choose the size of them. You can choose when you want them to come online, when you want them shut down. And with your SQL pools, like I said before, so our built-in serverless SQL pool is it just runs when you want it to run. And these ones are what used to be called Azure SQL Data Warehouse, or dedicated pools. You would pause them, you'd run them when you wanted to run them, and then you pause them. These bottom two are more expensive, but they're really good for processing massive amounts of data. This one kind of will deal with any level of data, and is cheaper to use. The downside is if you've got a lot of data, it's probably going to be a few seconds, whereas dedicated is going to be milliseconds to return that kind of data. Okay, so I think I am at time, so I'll pass this over to you, Taygan, to finish wrap up.
Switch it back. Thanks. Cool. Okay. So yeah, we'll just wrap up. I've just got 2 slides on resources, but yeah, hopefully you got a better feel for the toys that are in the chest box. There is a lot, but like I said, key takeaways that you don't need to use all of them. Your mileage is going to vary depending on the specific thing that you're trying to do. We've shown some common patterns, but there is Azure Architecture Center. So if you're interested in, hey, I've got like this really specific use case, has Microsoft already kind of done it before? Maybe I can reference a reference architecture, so that hopefully makes jobs a little bit easier. And things like Synapse, what Robin was walking through, while it has a lot of history with Azure SQL Data Warehouse, you can see it's kind of evolved over time, and now it's this kind of all-encompassing analytics platform, and that helps simplify the architecture. So rather than having 4 or 5 different distinct services, that one that only does integration and another one that only does data transformation, Synapse can potentially kind of simplify that architecture under one umbrella service, and there's less total cost of ownership. In terms of where to go to learn more, this is my own personal one, but I kind of share this with partners and customers around our certification program. I find it's a really good way if you're looking to build data engineers or data scientists or data analysts in your team. If you head on over to this link, so aka.ms/skills-poster, that's pretty much all of the Microsoft certifications all on one page. And we've grouped them up by the different solution areas. All those blue ones on the left are Azure, and I believe in the second column I've got all the data ones in there. And each of those tiles are clickable. So if you've got someone that's looking to become a data engineer, as an example, they can come in here, they can click on either the cert or the exam that cert belongs to. And if you keep drilling down, eventually Microsoft's going to suggest, here's a whole bunch of learning that we would recommend if this is the path that you're looking to take. And obviously the certification just lets them kind of validate that they've learnt what they need in order to pass that certification. Now whether they take the cert or not, I guess is up to the individual, but at least the learning material is there. And then speaking of the learning material, so aka.ms/learn, and that's where all of our modern learning content is going. So Microsoft Learn, it's all free, it's not behind a paywall, it's all kind of micro learning, so you can do a little bit of learning for a couple of minutes, you can do learning for an hour or 2 a day. It's really up to the individual, but it's all gamified. If you do log in, you'll get some points and gamification and badges and trophies and all that kind of stuff. But otherwise, it's all free content, and all the product engineers and stuff. That's where they're all throwing all the learning material, not just for Azure, but across all of Microsoft solution areas. And I think with that, it brings us to the end. So thank you. Yeah, Robin and I will stick around for a little bit longer if anyone's got any questions, but that's what we have. So yeah, thanks.